It's me. Hey, I was just thinking, we don't have to spend all day on math, do we? I mean, some of these things, yeah, take longer than others, but the lesson today, 10.5, surface area, you can see in the background, surface areas of pyramids and surface areas of cones. Let's get in, learn the stuff, get out, be done with it, do other things. Sound good? All right, then all we're going to do is we're going to talk about the formula for surface area of a pyramid, and then we'll do one example, and then the formula for surface area of a cone, and we'll do one example, and that should be good. So I'm using lined paper today. Ooh, aren't you excited about that? And I gotta find my, sorry, I guess I should have had this out already. Where's my good pen that works? And we'll go with this one. Surface area of a pyramid. Let's just remember that a pyramid, this is a typical pyramid like you would see in Egypt, right? It's got a square base and triangular sides. But not every pyramid has to have a square base. It could have a triangular base, and it would still have triangular sides. It could have like a hexagon base, and it would still have triangular sides. So all pyramids have triangular sides, but the base could be any number of shapes. Now, let's just make sure we know the difference between slant height and height. You can see it here. Height is how high the pinnacle of the pyramid is from the bottom, going straight perpendicular to the base. But slant height is from the edge down here, slanting upwards to that pinnacle. But if you notice closely, look at this pyramid, if you were just looking at this triangular side, the slant height of the pyramid is the same as the actual height of this triangle. Yeah? All right, so let's check this out. If we wanted to know the surface area, we would have to know the area of the base and the area of a triangular side, and then multiply by how many triangular sides you have. So that's all they do. So they unfold this thing, and here's the net of this solid, a pyramid. So we need to know this base area, and then we need to know the triangular area multiplied by 4. So what do you think that formula is going to look like? Let's see what they do. Surface area of a pyramid. Base area, area of the base, plus area of the other faces. Number of triangles, because the faces are always triangles in the case of a pyramid. Number of triangles, in our case we have 4, 1, 2, 3, 4, times the area of that triangle. Well, how are you going to find the area of this triangle? You're going to have to do base times height divided by 2. Base, whoop, this S letter, whoop, base, times height, L, or slant height, from the original shape, right? Base times height divided by 2. That'll give you the area of this triangle. Now what's interesting about this is to find this base of this triangle right here, that is the same edge as the side of this square, isn't it? So if I told you that the area of this square is 9, what would you know S would be? That area of that square is 9. Well, area of a square is side squared equals area. So if I told you the area is 9, what's the square root of 9? Because that's how you get rid of a square, right? The square root of 9 is 3. Positive or negative 3. In this case, positive 3. So S would then be 3. So to find this length right here, this base of this triangle, or the side of the square, you might have to think about the area of a square formula. All right, so there is that formula, and they give it to you officially down here. Surface area of a pyramid equals B, or area of the base, plus 1/2 PL. Wait a second. 1/2 PL? That doesn't look like what we saw up there, does it? That's because they take this formula up here, and let's see, number of triangles 4 times 1/2 SL. Well, that's, yeah, 1/2 base times height. Okay, and they rework that to make it a little easier to have 3 variables instead of, I guess there's 3 up here as well. Well, let's see how they figure this out down here. What does P stand for? The surface area of a regular pyramid is the sum of the area of the base and 1/2 the product of the base perimeter. Oh, P is for perimeter. Well, that makes sense. The perimeter of the base times the slant height. That might make things easier, don't you think? Perimeter of the base times that slant height, and then 1/2 of that. So, let's look at an example of that. Finding the surface area of a pyramid. Oh, check this out. This is a triangular base for this pyramid. So, slant height is 6. Isn't that the slant height? It's not the actual height of the pyramid, right? And then the bottom edges here are 8. So, let's find the perimeter of the base. And we get, by the way, the ticket for success here, guys, is always to write that formula. Let's see if we can remember it. Surface area of a pyramid, so surface area of a pyramid, sub P, equals base area plus 1/2 PL. L is the slant height, P is the perimeter, B is the area of the base. So, area of the base is roughly, they say here, 27.7. How'd they find that? They just gave it to us in this problem. Okay, sounds good. 27.7 plus 1/2. What is the perimeter? 8 plus 8 plus 8. 8 times 3 is 24. Times L. What is L? That's the slant height. That is 6. 24 times 6. And off we go, and you can figure that all out, and that comes down to 99.7. Now this is surface area, so what are the units? 99.7 square meters, because this is in meters up here. Okay, well that's easy enough. Let's go to the formula for a cone. You can use the net of a cone to find its surface area. Here's the net, right? The curved surface of a cone is part of a circle with radius L. This blue, so that's saying that this blue shape right here is part of a bigger circle, isn't it? A bigger circle with radius L. This is that slant height, the original slant height of that cone, isn't it? Okay, but that's the radius of this thing. So, surface area of a cone is part of a circle with radius L, the slant height of the cone. The area of this surface is A equals pi RL. Pi times radius times L. Interesting. Where R is the radius of the base of the cone. So it looks like we're going to do this. We need the surface area of this, or the area of this plus the area of this. So it looks like our formula down below here is going to be pi r squared for area of that plus pi RL. And indeed, that is the official surface area of a cone formula. So, see if we can remember that right now. Surface area of a cone. Throw this in your notes, of course, because I don't expect you to remember this a week from now. Put it in your notes, but for right now, see if we can memorize it. Pi r squared for the base plus pi RL. Fancy. Let's look at that example. Find the surface area of a cone with radius 4 meters and slant height 9 meters. Now guys, it doesn't take long to draw pictures. Boom, I just drew a picture of a cone, right? But it really helps. So, surface area of a cone with radius 4 meters and slant height 9 meters. Radius down here. 4 meters, slant height 9 meters. Okay? Remember the formula? Surface area of a cone equals pi r squared plus pi RL. And let's see, plug in what you know. We know the radius is 4, so pi 4 squared plus pi 4 And then L is 9. Pi times 4 times 9. Okay, that's it. Now just make sure, guys, that you do the 4 squared first. So that's going to be 16 pi plus, what's 4 times 9? 36 pi. 16 pi plus 36 pi, which will actually be 52 pi. You can do 52 times pi and get your answer. And what do they get here? They get 163.36 square meters. So that should be enough to get you on your way to success. Let's just take a quick gander at the assignment for today and see if there's any that look like they're going to be super hard. These, they give you all the necessary information. Round to the nearest tenth, don't forget that. Find the surface area of the net. Yeah, on this one down here, surface area of the net, oh, I guess 8 inches is that side, so you're going to be good with that. I think you're going to be golden. This challenge problem over here has a hexagon as the base, and then they have a slant height, and then they drew the hexagon base itself over here for you. But I don't think you're going to have that problem. So that was all. What are we at? 11 minutes? Cool. Have a good day.